Hi, I often come across clients who started their journey to the public cloud but struggle to understand how to align their availability requirements along with the cloud provider SLAs for their services. Sometimes they misunderstood availability as the same as system resiliency, but it's not because resiliency is all about how fast your system can recover from failure, whereas availability is the time when your system is available and serving users. Even uptime is not similar to availability. Your system can be up, but may not be in the state of accepting or processing request. In this short video, I will go through a typical multi-tier application that we will running on the public cloud. We will go through the cloud providers SLAs for the services we are going to use and calculate our out system outage or how long the system will be unavailable every year. But before we deep dive into application components and talk about the deployment architecture, I want to quickly go through and show you how we define availability. We generally use nines to calculate system availability. Like 1 9 or 90% shows 36 days of outage or downtime during the year, where 5 nines gives you not more than 6 minutes of system outage in a year. Now, availability requirement for our system are in 3 nines, which is 99.9%, which is around 9 hours of outage in a year. We need to design our infrastructure and choose cloud services in a way that satisfy our 3 nines availability SLAs. We start with configuring the network infrastructure. As a standard design, we will have a region where we are going to run VPC that will have multi-node subnets. We are deploying our app into the same subnet or zones as well as into second subnet that will add redundancy but will provide high availability uh, to our instances. We start with initializing availability, which is 100%, as we have not added any application component yet to the deployment infrastructure. The first component for us will be EC2 instance, where we are going to run our application. Cloud provider has a baseline SLA for EC2 instances, which is 90% in a single zone or a subnet, which also means that the failure rate for EC2 instance is 10%. As you can see, we got 4 redundant instances, which means we multiply our failure rate for all 4 instances, which is 0.01%. And then subtract the failure rate for all 4 instances from the initial availability of 100%. Now the new availability is 99.99%. Now you can already see the advantage of having redundant instances and how that help reduce the overall failure rate for the redundant components. In this case, EC2 instances. Now our application needs persistence. So let's add a second component to our architecture, which is RDS or Relational Database Services. Now we will make our database also redundant by deploying them into 2 different subnets or zones. Now cloud provider SLA for RDS is 99.95%. This SLA is already provided by considering the multi-zone deployment. We don't need to multiply them anymore. What we need to do is to multiply our EC2 instances availability with the RDS availability, and the outcome will be 99.94%. As you can see that our overall availability has reduced slightly from 99.99 to 99.94%, but this is still more than what we wanted, which is 99.9%. Now, this also shows that introducing more component or dependencies in the architecture will have a direct impact on the availability. Okay, let's add few more services to our deployment architecture. The next services will be EFS or Elastic File Service, which will provide file-based network storage to our EC2 instances to store configuration data. Now, this way we can decouple our configuration from the code and remove dependency from the EC2 instances. Whenever a new EC2 instance startup will have the access to the same EFS to read and start the app. Again, to derive the availability after adding EFS, we will use the cloud provider SLA for EFS, which is 99.99%, and then multiply it with the EC2 instance and RDS availability. And the new availability will be 99.93%. To add further loose coupling and remove the direct dependency from our EC2 instances when the user is sending a request to our app, we are going to introduce an Elastic Load Balancer that will provide the gateway to our app. But most importantly, the load balancer will manage the load between our multiple EC2 instances. The SLA for ELB is 99.99%, and we will be multiplying ELB SLA by our current availability, which is 99.93%. So the new availability after adding ELB is now 99.92%. So far, we have added multiple EC2 instances. We also added a high available database service and managed shared file storage and load balancer. We still have a single region dependency as all of our services are running in one region. But we do have multiple zones to reduce service unavailability due to zone failure, which is a reasonable design, but not globally distributed and highly available design. And there is a reason why I have not introduced multi-region yet to our deployment architecture. Because I want you to understand the limitations with the current design and then see how multi-region can address that limitations. Anyway, coming back to the availability, the current availability after adding all of these components is 99.92%. This is still more than our original requirement, which is 99.9%. Now, our application uses asynchronous communication between app components to provide component level decoupling. And for that, we are going to use a, a cloud native service called SQS or Simple Queue Service. The SLA for SQS is 99.9%. This is a regional or region-based managed service. So to drive the final availability after multiplying SQS SLA with the current availability, the new availability for our system is now 99.82%. Now this is slightly lower than our required availability, which is 99.9%. Now, the important thing to notice here is that using cloud native services certainly provides the right level of decoupling, auto scaling, and performance, but has an impact on the overall availability. And this is where introducing multi-region will address such limitations. Now, let's see how expanding our deployment into another region will improve application availability. To address our availability limitations with a single region, we decided to expand our architecture into two regions. Initially, we were running the app in London region. Now we has expanded into Ireland region as well. As we know, our current availability for each region is 99.82%. So let's calculate availability considering both regions. To do that, first get the failure rate for each region, which will be 100% minus 99.82%, and that is 0.18%. To calculate the combined failure rate for both regions, we will multiply both regions, and then the failure rate will be 0.0324. This is the outage when the application will not be available, considering Both reasons are active-active. To get overall availability, we are going to subtract the failure rate, which is 0.0324% from the initial availability, which was 100%. And the final figure is 99.97%. Now you can see that having multiple reasons will have a positive impact on overall availability requirements. But of course, it will add more cost. So let's summarize what are our findings so far. We started with our requirement for availability, which was 99.9%, around 9 hours of outage in a year. We wanted to have a balanced loose coupling in our architecture. Therefore, we want data processing, data persistence, storage, routing, etc. will be handled by separate components. That has reduced the initial availability but will give us more availability than what we required. Next, we introduced a cloud native service called SQS, which provides async messaging integration between apps and gives them the flexibility to change and scale independently to each other. However, that has reduced system availability further, and now that has gone below our required availability. But that's always the case. More flexibility, decoupling you will introduce to your architecture will have an impact on the overall availability of your system. To address this, we have decided to expand our deployment to multi-region. And that's turned out to be a game changer. As you can see, our overall system availability has increased significantly. So has our overall deployment cost. And that is the balance you have to find when you design your architecture for flexibility, which is loose coupling, versus availability, maybe using redundancy. When you have a redundant component, then you should be using the failure rate to derive the overall availability, as we have done in the case of EC2 instances or multi-region calculations. Finally, components that are dependent should be multiplied with overall availability, as we have done with RDS, EFS, or ELP. So that's it for this topic. Hope you get some value out of it. Thank you and see you next time.